Okay, so this is a condensed version of the Rheem Top Tech air conditioning training class. So we're going to go over some installation, some service, best practices, and some of the features and benefits. If you have any questions as we go along, just put it in the chat feature, and I'll bounce back and check on as we go along. So my name is Chris Elam. I'm the East Central service advisor. So I handle all Rheem products, Mitsubishi, and Climate Master. So I didn't include my contact information in the chat feature. Please take that down if you ever have any questions. If I can ever be assistance, please give me a call, send me an email. I'm happy to help you. So we'll get started here. So on installation, when you're choosing a location for a new air conditioner, a lot of times you don't have the option. You're putting it back to where the old one was, but you want to keep a few things in mind when you're finding that location. Refrigerant piping and wiring should always be properly sized and kept as short as possible to avoid capacity losses and increased operating costs. The further your line set goes, you will lose overall capacity after a certain point. So your 3-ton, for instance, is no longer operating at a 3-ton, and it will cost you more to operate. This is a big one for air conditioners and heat pumps especially. Locate the unit where water runoff will not create a problem with the equipment. Position the unit away from a drip edge. We've had a few this year where water and snow has dripped onto the blades. A couple of them actually caused the blades to bust because once it started, the vibration was so severe it actually cracked the blades. Also, when choosing a location, closely follow the clearance recommendations. You do want 24 inches to access the unit, to service it, and in this point while you're installing it. They do recommend 60 inches above for proper discharge, and then also 6 inches from coil grill inlets, but they really recommend 12 inches, minimum recommended. So it is important. The 60 inches discharge on top is real important. So you don't want to put it under decks with a very short clearance. You will end up with some higher than normal discharge pressures, and that will affect operation and operating costs. Also, you can shield it with a fence or shrubs. It will give it some protection. There again, don't violate the minimum airflow and service clearances. I've had to actually climb on top of them in the past, and service units kind of hanging upside down. It's not easy other than for just basic service, and it will affect operation if it can't breathe. In some cases, you have to elevate the unit off its slab or base to allow air circulation to avoid holding water in the base pan. Regular maintenance will reduce the buildup of contaminants and help protect the unit's finish. We don't really have coastal issues here, but a good coat of wax as you dry wax will keep that cabinet looking clean and not faded. Frequent washing of the cabinet, fan blade, and coil with fresh water will remove most of the salt. We don't have salt here, but other contaminants that could build up. They do recommend a regular cleaning and waxing. The finish will fade over time. It's a guarantee. It starts to look old, so a decent wax job once a year on maintenance is not a bad idea, and it's a good selling point for your maintenance. Customer satisfaction issues. The unit should be located away from living, sleeping, and recreational spaces for the owner. So you really don't want to put it next to a deck or an outdoor kitchen area. Try to stay away from bedrooms. best you can. To prevent noise transmission, the mounting pad for the outdoor unit should be not connected to the structure and should be located a sufficient distance above grade to prevent groundwater from entering the unit. If you are installing a unit on a flat roof, we don't see a whole lot in our region, but if you do, use a 4x4x4 or equivalent stringers positioned to distribute the weight evenly and prevent noise and vibration. Specific tools and refrigerant. All these units are 410A. Pretty much all the gauges nowadays are set up for 410A. Years ago, you had to have 2 sets. A lot of guys didn't even have 410A gauges, but you do have to have a manifold set up to 800 PSIG on the high side, 250 PSIG on the low side, a 550 PSIG low side retard. Your manifold hoses, service pressure rating of 800 PSIG. It is a good idea to replace your hoses over time. If you've never had one blow up on you, you're lucky. Sounds like a shotgun right off the side of your face. So if your hoses look weak and brittle, get you a new set of hoses because you don't want one of those to bust on you. Recovery cylinders, you do have to have a 400 PSIG pressure rating and DOT transportation 4BA 400 or BW 400. Replacement units. To prevent failure of a new unit, the existing line set must be correctly sized and cleaned or replaced. That's imperative. We have guys all the time that try to use existing line sets. They must be the correct size or it will affect operation and your refrigerant pressures and can cause almost immediate issues. Care must be exercised that the metering device does not get plugged. So if there's any kind of debris, dirt, it will clog up your TXV or piston if you're using a piston. So for new and replacement units, a liquid line dryer must be installed and refrigerant tubing must be properly sized. They provide the filter dryer with the unit. It's up to you whether you put it at the outside or the inside. People will argue both ways. Mainly you want to just make sure that it's included, and anytime that you open the system up, that it's replaced. If you're going to use existing line sets, do test the oil for acid. If it is positive, suction line filter dryer is mandatory to catch any acid and debris. Obviously, you'd want to treat it for acid before you even go that far. If you do have to install a suction line filter dryer, remove it after 72 hours. Don't leave it on there. It can become an additional metering device over time. Refrigerant level adjustments. All units are factory charged with 410A to cover 15 feet of standard size interconnecting liquid and vapor lines with a required filled dryer. Just because it says 15 doesn't necessarily mean you won't have to add any. Adjustment of charge may need to be necessary, even if the application has 15 feet of line set due to other installation variables such as pressure drop, vertical lift, and/or coil size. So for different lengths, adjust the charge as indicated below. Adjust the charge. So these are going to be your gross charges. So if you know your specifics on your line set, so if you have a 20-foot line set and you know what your fittings are, so you can add those up and then you can initially add additional line set. So if you have a 3/8 line and you have an extra 5 feet. So you would take 0.6 ounces times 5, and that would be your additional gross weight charge. Don't take that as being the end all charge. That just gets you close, so you know you're within the ballpark. But that's not going to be your final charge. We'll get into that later. Your liquid line selection, and we'll go over line selection later on towards the end, but the purpose of the liquid line is to transport warm, subcooled liquid refrigerant from the outdoor unit to the indoor unit. It is important not to allow.
Come on.
If you're not muted, do me a favor and please mute if you would. It is important not to allow the refrigerant to flash any superheated vapor prior to the expansion device of the indoor coil. The flashing of refrigerant can occur for the following reasons: low refrigerant charge, improperly selected line size, absorption of heat prior to the expansion device, excessive vertical rise between the condenser and the evaporator. So it is important that you follow the line chart, what's permitted and what is not recommended based on your unit size and then also your length requirements. Your suction line selection. The purpose of the suction line is to return superheated vapor to the condensing unit from the evaporator. Proper suction line sizing is important because it plays an important role in returning oil to the compressor.
Come on. Come here. Biscuit. Come here. Come on.
Okay, sorry about that. Also, an improperly sized suction line can dramatically reduce capacity and performance of the system. The procedure for selecting the proper suction line is as follows: the total amount of suction line needed, add all additional equivalent lengths associated with fittings, accessories, add the total length and your fitting pressure drop. This will equal your total equivalent length, and then reference to table 2, and then verify the capacity difference is compatible with the application. So ideally, you want to use the correct line size associated with your unit, preferably as short as possible with as few 90s elbows to lower your friction rate. Tubing installation. Observe the following when installing the correct size type L refrigerant tubing. Check on tables page 16 and 17. Like I say, we'll get that in towards the end. This is a big one. If a portion of the liquid line passes through a very hot area where liquid can be heated to form vapor, you must insulate that liquid line. Always use clean, dehydrated, sealed refrigeration grade tubing. Don't take your ends off until you're ready to make your connections. Always keep your tubing sealed until it's in place and connections are ready to be made. Used to see guys all the time, they'd pop the caps off and then they'd start running their line sets. Once you get debris in there, unless you take time to blow it out, which they never do, you'll end up with stuff that'll end up blocking your piston. It'll end up fouling up your TXV, your filter dryer. Always install a high quality filter dryer that will be included with your 410A unit. Must be installed in the liquid line unit. When replacing an R22 with a 410A and the line set is not replaced, clean any oil that is pooled in low spots in the line set. Sometimes you'll end up with some funny line sets that you'll create oil traps. So you got to get all that old oil out of there. Commercial flush kits are not recommended due to the risk of residual flushing agent being incompatible with POE oils or internal components. Up to 5% mineral oil is considered acceptable. Um, you definitely want to use a fair amount of high pressure nitrogen to flush anything that's out of those lines. Some guys still use flush kits, providing they use enough nitrogen with them and don't get chintzy on the nitrogen. They can usually flush all that out, but you do want to make sure you start with as clean of a system as you can possibly, start with. If you don't, a lot of times the problems won't show up immediately. It will start showing up, 4, 5, 6 years later with compressor failures and other issues. Tubing installation. If tubing has been cut, make sure the ends are deburred while holding in a position to prevent chips from falling into the tubing. That's huge. Any one of those little chips get in there, it can plug up a piston, it can plug up a screen, it can foul up your TXV. Burrs such as those caused by tubing cutters can affect performance dramatically. For best operation, keep tubing short as possible with a minimum number of elbows. Locations where tubing will be exposed to mechanical damage should be avoided. If it is necessary to use such locations, the copper tubing may be housed to prevent damage. If the tubing is to be run underground, it must be run in a sealed, watertight chase. Use care in routing tubing. Do not kink or twist. 3/8 is easy to bend. 5/8 so. 3/4 and up. Unless you're really, really good, you'll probably kink it. I always do. So if you're going to have to do any major bends, if you have a good tubing bender, that works wonders. It looks good, and that's one less braze joint or connection you have to make that can go bad. So it's always a good idea to use a tubing bender. And if you do kink it, don't leave it in there. Cut it out and start over. If you do have to use hangers, route the tubing using temporary hangers, then straighten the tubing and install permanent hangers. Make sure they're supported so they don't get vibration, because that will cause noise complaints, especially in heat mode. It will vibrate and sometimes sounds pretty violent. Blow out any liquid and vapor lines with dry nitrogen before connecting to the outdoor unit coil. Any debris in the line set, it will end up plugging the expansion device. I can almost guarantee you that. Tubing connections, indoor coils. So when you get a brand new coil, you're going to have a slight holding charge of dry nitrogen. Keep all the tube ends sealed until your connections are made. Excuse me. Use type L copper refrigeration tubing. Braze the connections with the following alloys: copper to copper, 5% silver minimum; copper to steel or brass, 15% silver minimum. Be certain both refrigerant shutoff valves at the outdoor unit are closed. A lot of guys are using the press fittings, and they've even got some, I'll call them shark bites, but refrigeration shark bite fittings now. So you don't even necessarily need to use a torch to braze it shut. So now when you are getting ready to braze, this is very important. We had a couple come back last year, valves that were leaking out of the top, and Rheem sent them to their engineers because we had two of them. They didn't. One looked really, really burnt. The other one didn't. Um, but they took them back and cut them open and verified that they were indeed cooked. So whenever you're going to do any brazing on the service valves, obviously remove your cap on top, Schrader cores from the pressure points to protect the seals because they do have seals and they will melt. Both Schrader valves and service valves has seals that may, they may and will be damaged by excessive heat. Make sure the inside of your fittings are clean. If you have any debris or chips, dirt, make sure that's out of there before you start brazing. This is a big one. I would recommend, number one, you have to use a wet rag of some sort, but I would recommend using a wet rag on each valve and also some thermal heat barrier. So protect those valves. You've got plenty of room there to heat sink it and then wrap those valves. The last thing you want to do is overheat them and replace a set of valves on a brand new unit. It's easy to do if you don't take the right precautions. Braze the tubing between the outdoor unit and indoor. Be sure to flow nitrogen into the lines as you're brazing. The purpose for that is to keep all that oxidization out of the inside of the line. All that black junk you see on the outside, if you don't flow nitrogen properly, all the black stuff, debris and scale you see on the outside will also be on the inside. And if you have 4 connections, 1, 2, and 2 on the outside, 2 on the inside, that's a lot of little tiny debris that will be floating around in your system. That's what's going to lead to, or used to lead to, piston failures. You don't see pistons that much anymore, but that will lead to piston blockages. It'll end up with clogged screens. It'll also cause failed TXVs. Expansion valves have enough problems on their own. Adding to it with additional debris and issues won't help your situation any. After brazing, use the appropriate heat sink. Use that cool rag to wipe it down, cool the joint. Reinstall the Schrader cores in both pressure points. And as you're running your lines, don't allow the vapor line and liquid line to be in direct contact with each other. This causes an undesirable heat transfer, resulting in capacity loss and increased power consumption. Leak testing. Indoor coils, they obviously come with a charge. Do not use oxygen to purge lines or pressurized system for leak. Oxygen reacts violently with oil, which can cause an explosion. Pressurized line set coil through service fittings with dry nitrogen to 150 psig maximum. If you're just doing a line set and coil, you could probably go higher, truthfully. They're being conservative there. Close your nitrogen tank. Let your system sit for at least 15 minutes. Make sure your pressure is not dropping. If it starts to drop, check your hoses, check your connections, do some leak test, soap bubbles. If you do find a leak, make the repair and then repeat the process. As far as your suction line, your vapor line must be insulated for its entire length to prevent dripping, sweating, and prevent performance losses. Closed cell installations such as Armaflex are satisfactory installations. If you're running through walls, ceilings, attics, even the slightest tear or missing section can and will result in moisture damage. It'll become very evident really quickly. As far as your wiring, This is going to be your low voltage control wiring. They do recommend not to run your low voltage wire in the same conduit with your line voltage. Low voltage wire may be run through the plastic bushing provided in the base panel and attached to the pigtails. A thermostat, standard thermostat, and a 24 volt 40 VA minimum transformer are required for the control circuit of the system. The furnace or air handler transformer may be used if it's sufficient, and most new ones should be a minimum 40 VA. Wire size, this is big. Don't use phone cord to connect indoor and outdoor units. Don't use phone cord, speaker wire. There's all kinds of funny little thin wires out there. This could damage the controls and may not be adequately sized for the control electrical load. So use your 18 gauge, is what's recommended between the thermostat and outdoor unit. Okay, your power wiring. It is important that proper electrical power from your commercial utility is available at the compressor contactor. Voltage is range below 208, 230 single phase. You have to have a minimum of 187 and a maximum of 253. If you're closer to 187, chances are your compressor is not going to start. Usually you're going to be in the 235, 246 range. What we see usually. If you start going way over 250 or higher up around 253 or above, you will more than likely sustain some kind of damage to the unit. Especially if it's an inverter unit, the closer you get to 253, the more issues you'll have. Same with 208, 233 phase, same voltage, 187, 253. 463 phase, minimum 414, upwards of 506. 575 three-phase, minimum 517, upwards of 633. It is important that your power wiring must be run in a rain-tight conduit. Conduit must be run through the connector panel below the access cover attached at the bottom of the control panel. Connect power wiring to the line voltage lug located at the contactor right here. Make sure all your electrical connections, including factory wire connections, make sure they're tight. Just because they're factory, don't necessarily assume that they're true and they're correct. While you're in there tightening these up, go ahead and make sure everything else is tight too. Do not connect aluminum field wire to the contactor terminals. It's been a long time since I've seen an aluminum wire out to a house, but do not connect aluminum field wire to the contactor terminals. Obviously, grounding is important in the unit right here. Next to your contactor, there is a grounding lug provided near your line voltage power entrance for a ground wire. Make sure that you utilize that. Now we'll get into the actual units themselves. This particular one is going to be on your single stage 13 through 16 SEER non-communicating. They're going to come in 18,000, 24, 30, 36, 42, 48, and 60,000 BTU models. They're available in both 208, 230 single phase, 208, 230, 463 phase, and all units will use 410A refrigerant and POE oil. All these units are matched rated for use with a TXV equipped evaporator coils and air handlers. So if you check the AHRI ratings, they're going to match them up with a specific Rheem coil or another manufacturer's coil, but they'll almost always be matched up with a expansion valve. So here's your basic unit here. Some features on these units. They're really easy to access. So you've got your four corners that access your coil. On the smaller units, you have one screw that allows you access to each panel. Larger units, you'll have three, one on top and two on each side. It's real easy to take the screw out, pop the panel up, gives you complete access to the coil for cleaning and servicing. And you can have that whole panel off within a few seconds for cleaning and servicing. These coils, they are single row coils, so they're super easy to clean and make sure they're clean. If they look dirty to you, they're probably dirty. So super easy to clean and service, unlike the older models. That's the easiest thing you can do on these is keep those coils clean and keep it running in tip-top shape. Standard features, Copeland ZP compressor, PSC outdoor motor, run capacitor, contactor, factory cooling down to 55 degrees, factory line set 15 feet, optional accessories, crankcase heater, hard start kit. Some models will include them, some models it's an accessory. Low ambient controls for all these models, time delay relay, and low and high pressure switches. Here's an explanation of the model number. So your first letter is going to be the brand. So in this case here, R for Rheem. If you're sure comfort, it'll be an S. RU, it'll be U. Your A stands for air conditioning. The next two digits is your SEER. So it's a RA13, 13 SEER. Next one is your capacity, 24, 2 ton. The next letter is A. This is your, I'll take that back. Your A is your major series. So as they change, you could have an A, B, C, D, F, whatever your series is. Your next letter is going to be your voltage. J is your single phase. C, 3-phase, 28230. D, 460. Y, 575. Go to your next number. In this case here, they're all single stage. It'll be a 1. The next letter is an N for non-communicating, and the A is the minor series. So as they make small revisions, this A can change, and this last A can change. And that will just denote minor changes. Could be a fan blade, could be a fan motor, could be height, could be any changes that they make. Component owner overview here. Now, one thing I like about these, they do have the composite base, which will help reduce sound because it's not a metal base anymore. You can damage them. They won't rot away. You can melt them if you get the torch, close enough to it. I've seen a few of those. But generally speaking, that's close to being indestructible base. Also, by your service valves here, you have a little, like a half moon behind your service valves that gives you access into compressor chamber there. 2 screws right here. You can reach in there. You can check reversing valves on heat pumps. You can reach in there and check your compressor temperature. Any number of things you need to get inside for without having to take the top off. And the way these are laid out, you have real easy access to your service valves for brazing, servicing. And the one thing I do like on each side, next to each service valve, there's 2 little trays, 2 little indention trays that you can put your caps in, as well as your Schrader cores, whatever. So it makes it nice so you don't lose those. Get your Copeland ZP compressor, designed to deliver 2 to 4% more efficiency over previous generations. Single and 3-phase configurations. Uh, Electrical configuration is a run winding is going to be your red wire. Start winding is going to be your purple. Your common is going to be your black. And your orange wire is going to connect your run winding to the common of your compressor. Now, if you cross these up in the right combination, um, I get this quite often. Guys just start putting things back together, or somebody else does it and don't pay attention. If you miswire these, what you will get will be what looks to be like a lock rotor compressor. You know, it'll sound electrically amp draw. It'll look just like a locked rotor compressor. So if you have a new unit or you're replacing a compressor, and all of a sudden you get locked rotor amps, um, obviously check your capacitor. But next thing is go back and verify that your wiring is correct. Runs red, starts purple, common's black, and make sure your orange is going to the common side of your capacitor. It does have built-in discharge temperature protection. Now this is important to know here. Invariably, you'll come across overheated compressors. The temperature-sensitive snap disc is located between the high and lower pressure side of the compressor muffler plate. So, kind of know where that is, so to where you can direct your water to cool down the compressor. Your motor overload protection provides conventional internal line brake motor overload protection. What it's going to do, it's going to open up the common side of your single phase motors and the center of the Y connection on three phase. So if you have an overheated compressor and you start ohming your windings out in your compressor from your contactor and your capacitor, you'll end up with two open windings. And then if you reach in there and you touch your compressor, chances are it's going to be extremely hot. If it's really, really hot and your windings are open, get your garden hose out, start cooling it down. Usually if you kind of concentrate right through here, when you're cooling the compressor down towards the top, it doesn't take long to get them to reset. This is a big one here. This goes for Copeland and pretty much any compressor. Circuit breaker trips. If you come across a unit and it has a circuit breaker tripped, and you reset it and it trips again, don't keep resetting it. There's a reason that it's tripping. So at that point, you'll want to come out and start checking to see what could be shorted. If the breaker is reset without checking for a motor short continually and a short is present, the compressor can vent a motor terminal pin. This is called a terminal vent. I'm sure you've come across compressors before where it's actually blown one of the pins out. That's a terminal vent. I had one time that blew out pretty much right in front of me on an old Linux. If you're not expecting it, it'll have you jumping. So don't necessarily just keep resetting your circuit breaker. This is a big one too. Removal of the compressor from the outdoor unit. Never use a torch to remove the compressor. After proper evacuation of all the charge in the system, it is best to use a tubing cutter to remove the compressor. If all the refrigerant is not recovered, trapped refrigerant in the compressor shell under the refrigerant oil can flash, can cause an oily foam to vent from the compressor, and then using the torch can ignite the foaming oil. Guy I used to work with, he always made everybody cut them out. I mean, not cut them out, made them unbrazen because he thought it was funny to watch them, the big flash of oil. Most times nothing happened, but be safe. You know, cut out your compressor. Don't remove it that way, because you can end up with a big oily fireball. Three-phase scroll compressors will only compress gas in one rotational direction. Direction of rotation is not an issue with single phase, since they always start and run in the same direction. You can occasionally get them to run backwards, but you'll know that because of the noise. Three-phase compressors can rotate in either direction depending on phasing of the power. Verification of proper rotation direction is made by observing that suction pressure drops and your discharge pressure rises when the compressor is energized. Reverse rotation will result in no pressure differential as compared to normal values. If it's running backwards, just switch one of your legs of power, and that will reverse the phase. Startup of a new or replacement compressor. When charging a system with a scroll compressor, charge liquid into the high side only. It is not a good practice to dump liquid refrigerant from a refrigerant cylinder into the crankcase of a stationary compressor. If additional charge is required, charge liquid slowly into the low side of the operating system. Do not start the compressor while in a deep vacuum. Internal arcing could occur. And do not operate a compressor without enough system charge to maintain at least 55 psig. Do not operate with a restricted or suction dryer line. Do not operate with a low pressure cutout disabled. And then allowing suction pressure to drop below 55 for more than a few seconds may overheat the scrolls and cause early bearing damage. So compressor pumping issues. Okay. There are many misunderstood facts regarding compressor pressure related capacity. High suction pressure and low condensing pressure will achieve peak performance. As the suction pressure drops and your condensing pressure rises, the system capacity drops. Scroll compressors do not have valves, so therefore there is no valve test like with the older reciprocating compressors. If the compressor starts, the suction pressure should fall and the condensing pressure should rise. If this happens, your compressor is pumping. If a compressor is operating with excessive vibration, metallic sounding operation, or higher than normal amperage, the compressor more than likely has internal damage and you'll have to get a new compressor. There again, it is highlighted, never use a torch to take out a compressor. Always cut it out with a tubing cutter. Some unique features of scrolls. Couple highlights here. Starting kits are not always needed because the scroll components always start unloaded, even when the system pressures are not balanced. This is a big one, so if you're using a Megger or a Mega Ohm tester, if you meg a scroll compressor, it can result in an invalid reading due to the position of the scroll compressor in the motor oil. So you could take 50 brand new scroll compressors, and if you meg them, they're almost always going to read bad because it's giving you a false reading. Center bearing wear at the bottom of the compressor can be excessive when liquid floodback or liquid flooding occurs. The bearing wear can lead to rotor drag on the windings or a direct short to ground. So your basic sequence of operation for a normal single stage AC, the outdoor unit receives a 24-volt call via the thermostat wire. The 24-volt travels through any accessories that you may have included, low pressure, high pressure switches. If it's equipped with a time delay relay, it's going to stop in the time delay relay for whatever time frame that you have. A lot of them are 5 minutes. So after your delay, if it's in the system, at that point, 24 volts hits the contactor, and your solenoid is engaged. Once your solenoid is engaged, the fan motor and the compressor should turn on simultaneously. Once the line voltage is applied to the fan motor and compressor, circulation of the condenser air begins. The compressor begins to start, and the optional start capacitor, if that's in there, provides additional starting torque. That just makes the compressor start a whole lot easier. If you have lights that are dimming sometimes, usually the addition of a start component will reduce the lights dimming. As the compressor motor begins to come up to speed, the back EMF from the compressor start winding energizes terminal 2 on the potential relay. At that point, the potential relay will open up and drop out your start capacitor. Okay, now normal startup, so on initial startup or extended periods of shutdown, they recommend that you have the crankcase heater energized for at least 12 hours before the compressor is started. That's probably not going to happen in the real world, but you know, if you can, obviously power it up. Even though the unit is factory charged with 410A, the charge must be checked against the charge table attached to the service panel and adjusted if required. Now this is a big one here. Allow for a minimum of 15 minutes of runtime before analyzing the charge. At least let it run 15 minutes. It takes a good 15 minutes before it really starts to stabilize. If you have two-stage units or inverter units, you really need to let those run 30 to 40 minutes before you start making adjustments. If you make adjustments too quickly and then bail out before it stabilizes, it's easy to overcharge it. Now, airflow is critical for all new systems. It doesn't matter brand. The air distribution system has the greatest effect on airflow. The duct system is totally controlled by the contractor if you designed it, or if it's existing, it's with the house. For this reason, the contractor should only use industry recognized procedures. The correct air quantity is critical to air conditioning systems. Proper operation, efficiency, compressor life, humidity control, and outdoor unit capacity. If you have excessive indoor airflow, increases the possibility of high humidity problems. We see that quite often. Low indoor airflow reduces the total capacity and can cause your coil to freeze up. Serious harm can be done to the compressor by extremely low airflow, such as that caused by refrigerant flooding. So it's important to understand, number one, what size system that you have, how much airflow is needed, can your duct system handle the airflow? So if you do have humidity issues, you can usually slow the fan down slightly as long as you're within a certain range, and that's going to give you better dehumidification. Air conditioning systems require a specified airflow. Each ton of cooling requires between 320 and 450 feet CFM a minute. See the spec sheet for rated airflow for the system being installed. They used to say 400 CFM per ton. Yes, that will work, but it may not dehumidify like the customer wants. It may not cool like they want. It may be loud. So depending on the system that you're putting in, uh, don't take it for granted that it's just 400 CFM per ton. And then you also have to factor in static pressure as well. So if you want to check airflow, there's some equations down here, but one big thing is air supply diffusers must be selected and located carefully. They must be sized and positioned to deliver treated air along the perimeter of the space. If they are too small for their intended airflow, they will be noisy, they'll whistle. If they are not located properly, they cause drafts. So like some of the houses in downtown Indy that are really old, they were never designed for air conditioning. They'll have the returns on the outer side of the room and the supplies on the inner side, which is fine. But the problem is when you're really cold outside, you're getting that cold against the outside of the structure. That's going to be drawn into your return because it's sitting by the wall. And then your hot air is actually being blown out from the indoor. So those homes are really hard to balance out because it should actually be reversed. Return air grills must be properly sized to carry back to the blower. This is a big one. If they're too small, they will also cause noise. They'll make like a humming or a high-pitched whistle if they're too small. So it is important that the installers or the salespeople understand what the duct system is. In a quick glance, you can see, what it looks like, what it should be able to handle, to ensure you install the proper furnace, airflow, and AC system. But you can also determine what your airflow is. So if you have an electric furnace, so what you're going to have is you can determine your CFM by taking your electrical resistance heaters. What is your voltage to the unit, to the heaters? Check the amperage, the actual running amperage of all the elements. Times that by 3.413. Divide that by your sensible heat constant, which is going to be typically at our level 1.08. So then you would take 1.08 times the temporize of the system. Temporize being the difference between the supply and return, and then you'll divide those two. That will actually give you your exact system CFM. So just because you have your blower set on high speed and you think it's putting out 1250 CFM, that really doesn't mean a whole lot. I mean, yes, in theory, you're in the right ballpark. But then based upon static pressure, filter drop, all kinds of different things, you may not truly be getting what you think you're getting as far as CFM. So just a simple checkup on this. You can do this with gas furnaces or resistance. So your gas furnace, you'll take your output capacity. So we'll say if you have an 84,000 BTU output, 90% gas furnace, you'll take your 84,000, divide that by your sensible heat constant, which is 1.08, times your temperature rise, and then that will give you your exact CFM. If that CFM matches what you think is adequate, you're okay. If it's way too high, you're moving too much air. Furnace could be oversized. You could be on too high of a speed tap. If it's way under, then you might want to start digging into your static pressure. Are you too tight on your supply? Are you too tight on your return? Now we'll get into evacuation and leak testing. This kind of goes over not just this particular class, but all classes. Um, Evacuation is the most important part of the entire system procedure. The life and efficiency of the equipment is dependent on basically how it's set up, the thoroughness exercised by the serviceman or installer when evacuating air and moisture from the system. Air or nitrogen in the system will cause high condensing temperatures or pressures, which will result in increased power input and non-verifiable performance. Now, you'll be able to tell that because you will see, in some cases, you'll see your head pressure bouncing up and down, up and down. I've had my old manual gauges where they would actually vibrate, actually physically vibrate my hands. If you ever come across the head pressure and it's just bouncing up and down, you've got non-condensables in there. Somebody didn't take the right procedures when they were setting that up. Another thing is moisture will chemically react with refrigerant and oil to form a corrosive hydrofluoric acid. This attacks the motor windings and parts, causing breakdown. This doesn't take place immediately. This takes place 4, 5, 6, 7 years down the road. And that's when you start losing a compressor. A vacuum should be pulled to a minimum of 500 microns. They don't go into great detail here about a triple evacuation. Years ago, I started doing a triple evacuation on every service call, every time I put in a unit, anytime I opened up a system. Um, it may have taken me an extra 25, in some cases 15, 20, 25, 30 minutes. But when I left there, the system was clean, it was dry, and the odds of me having to come back for either moisture, non-condensables, or a leak was non-existent. It's much cheaper to spend the extra 15, 20, 25 minutes, even an hour. That's a lot cheaper than having to come back on a callback for leaks that were missed or non-condensables. They don't really go into the triple evacuation here. With these new vacuum systems, if you have a good pump, clean oil, and the large, I can't think of the brand name, but the large vacuum hoses and the right setup, you can suck it down to a 500 micron quickly. Problem is you're drawing it down so quickly, so fast, that you can still end up with moisture in the system even though you're at 500 microns. So the ideal way to do that would be to, say, get down to about 4,000 microns, do a quick nitrogen purge, then draw it down again to 1,500 microns. Once you reach 1,500, do a quick nitrogen purge, then draw down to 500 microns. Once you get down to 500 microns, let that sit and verify that it does not rise above 500 microns. So that's every service call, every installation. I can't tell you how important that is. Even the few extra minutes that takes, and then your vacuum pump. I know guys that used to change their vacuum pump at the beginning of every summer, and let it roll all summer long. But if you're in the field, service, installation, um, we do get paid by the hour, by the job. But it is important to do a good, thorough job. Changing your vacuum pump oil, vacuum pump oil is cheap. Once it gets clogged and with contamination, it has to work 4 and 5 times as long to truly, and it'll never suck it down like it's supposed to. So usually, if you're doing a lot of service or installation, vacuum pump oil is cheap. Change that, 2, 3 times a week. That will speed up your vacuums. It will ensure you get a nice, deep, true vacuum. So this goes back into the evacuation again. But it is important once you get to 500, your final 500, watch it, make sure it doesn't start rising back up again. If you get it to 500 and it starts climbing, 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 uh, you've got a leak, or you got a leak in your hose, a leak somewhere, um, where you're letting moisture in, and that's what's killing your vacuum. So charge for all systems, all the current Rheem platforms. This goes for Rheem, Weather King, Sure Comfort, Rude. Um, they'll have the charging charts inside the service panel. So that's very important that you use those. Don't just operate on the swag method. Rheem, because you should be have matched up to a matched Rheem coil. So if you follow the charging chart, makes your life a whole lot easier. Important, do not operate compressor without charging the system. Addition of R410A will raise high side pressure. Notice system maintenance is to be performed by a qualified and certified technician. The following method is used for charging in cooling mode. So if you're in, if you have an air conditioning, it's specifically going to give you cooling mode charging. If you have a heat pump, it'll give you options for both cooling and heating. Service tip, this is huge. Not as imperative on air conditioners, but heat pumps, it can make the difference, whether you're right or way wrong. Verify the indoor unit orientation. So you make sure you use the correct charging chart, which we'll go over a charging chart here in a minute. There can be a difference. It just depends. Unit to unit's all different. It's not as severe on air conditioning only. There can be a difference between upflow, downflow, horizontal left, or horizontal right. So if you don't know what you're looking at, and you look at the wrong chart, you could literally be way off. Like I said, it's not so severe in cooling, but in heating it is. So when you're setting up your gauges, your red hose, for those who may be new, your red hose, your red gauge should be hooked up to the small line, your liquid line. Your blue gauge, blue hose should be hooked up to the larger line. With a TXV, you're going to check subcooling. So you're going to hook up your temperature probe on your liquid line and compare the line temperature of this line to the line temperature of your compound gauge right here. A lot of guys I see, in fact, most I see, they're using some sort of digital gauges, whether it be like the S-Man field piece, or a lot of guys are going to the Bluetooth now, where everything's Bluetooth, and all you have is your probes clamping on. So all those, they'll give you the superheat subcooling. It's basically all built in to the program for you. So that takes all the guesswork out of it. Years ago, we had to carry a probe similar to what you see in this picture here, and then hook it to my meter and then turn it on temperature and compare that temperature to my gauge, which is fine. It's not rocket science. But with those new digital gauges, whether you're using an app or you're using like an S-Man, it tells you exactly on the screen what your superheat and subcooling is. They take all the guesswork out of it for you. So when you're checking your charge, this is huge. So if you're putting one in the wintertime, you can weigh in some additional charge if you need to, if you follow your chart. And that's going to be basically what they call gross charged. It's a weigh in. So you assume minimum 15 feet. Um, take into consideration additional lines, additional fittings, and you'll be in the ballpark. So for gross charging, you want to run the unit for a minimum of 15 minutes prior to noting pressures and temperature. If it looks off at first, just let it run. Unless it looks way, way off, that's one thing. But if it looks a little bit off, let it run 15 minutes. It should be stabilizing by that point. At that point, you can start making your minor adjustments. Important, indoor conditions. Indoor conditions should be cooling mode around 80 degrees. Dry bulb heating 70 degrees. If the indoor temperature is above or below the range, run the system to bring the temperature down, or run the heat to bring the temperature within this range. System pressure values provided in the chart for outdoor dry bulbs to the corresponding conditions. If you have an indoor temperature of 50 degrees, it's going to be really hard to charge an air conditioner. So kind of bear that in mind. Usually you're going to be realistically anywhere from 70 to 80 degrees typically. So you should be somewhat within the ballpark. So once you finish up your installation, this is huge. Disconnect your pressure gauges from your ports. Check your Schraders, make sure they're not leaking. The big thing is make sure you put your port caps and your Schrader caps on. Don't leave those off, because if you do, people catch that and then they complain. Don't over tighten them. Don't put leak lock and all that stuff on there. You shouldn't need to do that. Replace the service valve caps, finger tight. If it has some of them have a wrench in where you can tighten them up. Don't over tighten them. You don't have to put too much torque on them. Replace the control box cover, secure panel, install all screws to the service panel, and restore power to unit if it is disconnected. Configure your indoor thermostat per customer's request. Now, the way I always do it, once I finish up, I'll go in there. I want to turn the system off. I always do this on every job, whether it's heat, cool, whatever I'm on. It's up and running. Go in there, turn it off, let everything cycle down, turn it back on. So once you turn it back on, you can verify the furnace or air handler kicks in, you're blowing air. Go outside, make sure that if it's calling, your outdoor unit's running air, and at that point, you're safe to go. We used to chase guys, after winter, or even tune-ups even. You guys will leave disconnects off, things like that. So if they do that, they haven't obviously done a good job checking to make sure it was running when they left. So always cycle them off, cycle them back up. That way you can verify at the time you're leaving, everything is functional as it should be. So as you get into some diagnostics here, some cooling mode troubleshooting tips. Usually an overcharge is kind of obvious to see. You'll see your discharge pressure will be high. Your suction pressure will be high. Superheat's usually going to be extremely low. And then your subcooling is going to be high. And your compressor amperage is going to be high because you got too much refrigerant in the system. So a lot of those you can kind of just see within a couple minutes what's going on. Undercharge, similar. If you have a very low discharge pressure, a very low suction pressure, usually at that point your superheat's going to be extremely high because it's not cooling. Subcooling is going to be extremely low because it's not cooling. There's not enough refrigerant in the system. And the compressor amperage is going to be low because it's not working very hard, to run. So usually undercharge is kind of it's not always obvious, but a little more obvious. Liquid dryer restriction. A lot of times, now this can be funny because if you have the liquid dry, if you have a restricted dryer, you can actually end up with high discharge pressure um, if it's sitting right outside the unit. Um, so, uh, so conceivably, you could have high. They're saying low. Suction pressure would be low because it your refrigerant is actually flashing, so it's being metered at the filter dryer. So that is the first metering device. At that point, it's hitting your TXV or your piston. You'll also have very high superheat because it's not going to cool. You'll also have high subcooling because it's not metering properly. And since it's not working super hard, you're going to have low amperage. Another big one is low airflow. A lot of times you can hear that if you have a motor that's going bad. It just doesn't sound right. It just sounds weak. Or if you have a super clogged up filter or a super clogged up coil. The way I run service calls, and the same way I've ran since I started. When I get there, first thing I'm doing is I'm checking the filter because if it's you know, if you got a dirty filter, strike one right there. Let's get that corrected first. Next thing I'm looking at is the blower wheel, blower motor. Is my wheel super clogged up? Is it dirty or is it in decent condition? Uh, Next thing I'm going to look at is my evaporator coil. Some gas furnaces are easy to access them, some of them not. Air handlers are always pretty easy to see. But if I make sure on the inside, filter's clean, blower wheel's clean, coil's clean, I just ruled out a whole lot of different problems without even struggling too hard to do so. So if you have low airflow, obviously your discharge pressure is going to be low. Your suction pressure is going to be low. Superheat is going to be super low. Subcooling is low, and compressor amperage is going to be low. Now, my favorite ones are the dirty outdoor coils. On a real hot day, if you have a dirty coil, if you put your hands on the units, it's going to be hot because that coil is cooking. If you touch that coil, it's going to be hot. Another way to prove that, for instance, I will take a blade of grass and I will toss it at the coil, because if it's clean and it's actually flowing freely through the coil, it should take that blade of grass, suck it right to the coil. If I take a blade of grass or something, dollar bill even, whatever, and I toss it at the coil, if it just drops, that tells me my coil's dirty. If it looks dirty, it probably is dirty. If it looks real dirty, it's probably worse than it truly looks. Dirty outdoor coil is going to give you high discharge pressure and a high suction pressure. A lot of times, a dirty coil, it'll still cool on a mild day. It just won't cool for anything during a hot day. Because what you're getting or what you're seeing is not real pressures, because they're being tricked by the dirty outdoor coil. So your superheat will be super low because you're not really going to be cooling or not cooling like you should. Subcooling will be low, and a dirty outdoor coil is going to cause your amp draw to go up considerably because the unit can't breathe. Now, once you clean the outdoor coil, at that point, make sure you wait, let your system run, and recheck your charge. Because once that coil is clean, you may have to make some adjustments. Lower outdoor ambient temperature. So if you're trying to charge it on too cold of a day, you'll have low discharge, low suction. You will have high superheat, high subcooling, and low amperage because you're not really working that compressor too hard. If you have an inefficient compressor, this kind of goes back to more of the reciprocating compressors. If you have a damaged scroll, it's usually kind of obvious. It'll be kind of metallic and clangy sounding, and sometimes it sounds downright violent. But if you had a low inefficient compressor, you could have a low discharge pressure and a high suction pressure. You could have a super high superheat because it's not cooling, super high subcooling, and low amperage. And then we get into the TXVs. Your indoor TXV bulb lost its charge, so you could have a low discharge pressure, low suction, high superheat, high subcooling, and low compressor amps. You could have a poorly insulated bulb or a misaligned bulb. So you could have a high discharge pressure, high suction, low superheat, low subcooling, and you'll have high compressor amps. It's not a lot of times what you'll see when you walk up to a bad TXV is your suction pressure won't be bottomed out, but it'll hang out just below. It'll hang at about 20 degrees. 15, 20 degrees, which is going to freeze it up. If you think, well, I'll just add some refrigerant, get this juiced up a little bit. What happens usually if you have a bad TXV where it's not going to change, it may go up slightly, but your discharge or your head pressure is going to jump up high, or jump up higher than it should, but your suction pressure will remain the same or go up about 10 psi and drop back down again. And I'll get into in just a minute how you can exercise your expansion valve to kind of test that. So troubleshooting TXVs. TXVs seem to be the biggest pain. They're not that difficult. A lot of times it's not their fault. You get dirt, debris, junk in there, and it fouls them up. So if you're flooding your evaporator, could be due to an undersized or inefficient compressor. Low superheat setting. So if you have a adjustable TXV, which really wouldn't come into play with most residential TXVs, they're already preset. You could have moisture. You could have dirt or debris that's causing the valve to stick open. TXV seat leak. You could have an oversized valve. Incorrect bulb position, where you could have a plugged up equalizer tube. TXVs that hunt, this is not uncommon. You can usually see that because your suction pressure will jump up and down a little bit. If you see it hunting, just kind of let it go. It should find its happy place shortly, hopefully. If it keeps on hunting, could be the valve is oversized for the application. You may have the bulb in the incorrect location, which we'll get into in just a few minutes. It's important on location, insulation, and make sure it's secure. Refrigerant distribution, superheat adjustment. Like I said, most of the residential are already preset, or you could have a lot of moisture and contaminants in the system. So if you have a starved evaporator, could be due to moisture, dirt, and debris causing the TXV to close. Insufficient delta P across the coil. Could have an undercharge system. Because TXVs are funny. When you're charging them, sometimes as you're charging it, your suction will go really high. You think, I got too much in here. Your TXV will throttle as it needs to maintain the proper superheat based on your subcooling. If you have a valve that's too small, if you have a superheat that is adjusted too high, allowing too much charge to flow through, or I should say not flow through, but not enough charge to flow through. Power assembly failure or partial loss of charge. Sometimes you'll end up with a locked up TXB where uh, basically that refrigerant coming out of the outdoor unit is hitting a brick wall because it's slammed shut, won't let anything through or very little. Other times it's just going to be partially shut, which is what we see usually. No. Now mounting, these are important. Rheem actually gives you a nice mounting clip. They set it up for you to mount the bulb outside the coil, so it's easy to access, easy to mount. The bulb must be securely fastened. Well, if it comes with two straps, or Rheem has the one solid strap, to a clean, straight section of a line. Don't mount that on a joint because you will not have proper bulb transfer. If a vertical, ideally you want a horizontal run. If not, you can do vertical, but the bulb must be mounted so the capillary tube comes out the top. So this is going to be your typical Rheem expansion valve right here, your bulb, suction line. This is important. If you ever have to replace one with the Rheem, you only have your two screw-on fittings here, so you don't have to worry about a torch. So you've got your small connector here, you got your two lines here. You will have two O-rings coming out each side of here. Make sure you remove the old O-ring and make sure you install the new O-ring in each side. If you don't, it will leak. It doesn't matter how tight you get it, it will leak. So make sure that your O-rings are in there. Make sure your bulb is secured. Ideally, you want to use a 10 or 2. This is a side view, so you want to do 10 or 2. Don't mount on the bottom. You will get incorrect readings. So what they're saying here is if you're going to mount horizontal, what they're recommending is a 10 and 2 with your pigtail closer to the bottom. If you have to do a vertical, that's fine. Make sure your pigtail is pointing up. Okay, well, you're checking the expansion valve. This is actually fairly easy because with Rheem, it's actually outside the cabinet. So the best way to check this is to remove the remote bulb of the expansion valve from the suction line. You can start the system. Two ways you can do it, or both, to verify you have a good test. First, you can cool the bulb in a container of ice water. Excuse me. As you cool that, the suction pressure should drop dramatically, and the suction temperature will rise. If you put it in a glass of ice water and you get little to no change, you've got a problem. You can also warm the bulb up. For years, we just put it in our hand, hold it and run outside and check. But you can also put it in a little glass of warm tap water. At that point, your suction pressure should rise dramatically and your suction temperature will fall. So if you get little to no rise, when you're going to the extremes of ice water and warm to hot water, then you've got a bad expansion valve. It's probably in your bulb that's not allowing it to sense. So if a temperature or pressure change is noticed, the expansion valve is operating. So if you go from normal to super cold, it should be a dramatic change. If you get like a 5 psi change, you've probably got an issue with the sensing bulb. For sure, if you get no change at all, then it's definitely got our issue. At that point, recover the charge, replace the valve, dryer, evacuate, and recharge. And it is nice that you don't have to use any torches. All you need is a couple opening and wrenches, and you can change the valve out. So here's your typical charging chart I picked a 14 SEER air conditioner. So we'll take a 3 ton. So if you go to the 1436, you'll see here it says all coils, multi-position. So that means it doesn't really matter what coil or what orientation your furnace is in, you can use this chart. Other charts that'll tell you upflow, or it'll give you specific coils. It may say one coil, upflow, downflow, horizontal, right or left. That's where it's important to understand what's my furnace orientation if it calls for that. In this case here, it doesn't matter. So we'll come down here, 1436. We'll go to 82 degrees. We'll come over here. Our gross pressures is 320, 134. Now, rarely will you get exactly that, and don't take that as written in stone. That's just your gross pressures. If you're close to that, you're in the ballpark. At that point, you want to take your 82, come down to 82, come over to your 36 again. So you need 15 degrees subcooling. That's what you're required is. Don't go over the 15. If you need to undershoot that a little bit, do like a 13 to 15, and you'll be fine. But don't overshoot it too much, or you may end up with a high pressure issue. So it's that easy. So if you're on a 95-degree day, come over here. Same thing. Gross pressures of 383, 137. You're in the ballpark. And don't keep charging until you get to that point and trying to achieve that. Once you kind of get to the ballpark pressures you're looking for, then you'll come down here and check your subcooling. If you're high on your subcooling, you've got too much. If you're low on your subcooling, slightly add, let it circulate, let it stabilize until you reach, in this case here, 15 required, gets you to about a 13. 13 to 15, you'll be perfect. And this is about the line set selection. If you sell jobs or if your service or installation, it is important to understand what you're dealing with, what's allowed. So you can come over here, if you're going to do a 2 ton, for instance, it will tell you what's allowed. So a quarter inch and 5/8, you'll see here it's not recommended in any of these models, but you could do it because you can come over here, 5/16, 5/8. You can come over here. Ideally, you'd want to do a 3/8, 5/8. You're good up to 75 to 100 feet. 3/8, 3/4. You'll see here, and 2 ton. You can go all the way pretty much as far as you want to, and you're fine. So it gets more critical with the larger the tonnage. It does make a difference. If you start trying to skimp on the line size, smaller ones you can get away with a little bit more. The bigger the units, you try to get by with anything less than a 3/8, you'll end up with problems out of the gate. So if you have any questions as far as if the line set is correct, in every installation manual, this is in here, and it's also in the specification sheet. So just figure out which tonnage you have, see what line set you have, 3/8, 3/4, and you're good up to about 125 feet with a 3/8 3/4. You know it's acceptable. You can go further. You'll see this kind of a darker shaded gray line. At the further you go, you'll see this 0.96, 0.95. You start going down, you'll start losing capacity. So in this case here, 3/8 3/4, you're pretty much fine with very little loss up to 125 feet. But as soon as you cross over that, you start going into this, you start losing capacity. If you see this darker shaded gray where it says NR, once you cross into this line, then you're kind of on your own. It's not recommended and it's not really rated, so it may work, it may not, but as long as you follow these guidelines, you'll be okay. Okay. Well, try to get you guys out of here a little bit early. I know it's hard to watch a computer for a super long period of time, but does anybody have any questions?
I have a question.
Yeah.
Just I'm actually really new to HVAC, so all of this is a little above my head, and I did my best to follow along, but I was driving for the first half hour home from work. Is there access to the PowerPoint presentation so I could review some of this again on my own time?
There will be. Every Monday, they'll send out an email
Okay.
from Jay Larson. If you follow towards the bottom of that email, it'll say previous recordings. You can access them there.
Okay. Awesome. Thank you.
Yeah. So usually, if it's done today by Monday or Tuesday, they'll have that set up for you.
Okay. Thank you.
And then you can you're welcome. Any other questions? Okay. Well, like I said, I did put my name, phone number, email. If you have technical assistance, any questions, feel free to call me anytime. Do appreciate you taking your time out to attend this today. And if I can ever be of assistance, please let me know. So y'all have a good day. Thank you very much.